So last time we talked about the power rule when we're using the exponents, and today we're going to talk about the quotient rule, which is what we use when we divide monomials. So the quotient rule is just showing that when we have our monomial divided by our monomial, same bases, different exponents, we want to subtract the exponents. So if you have x to the a power divided by x to the b power, your answer is going to be x to the a minus b power. So let's try some examples. For number 1, we have x to the 5th divided by x to the 3rd. So our base is x, and we just need to subtract our exponents. So 5 minus 3, that's going to be 2. So our answer is x squared, or x to the 2nd power. Now make sure when you're talking about these that you're saying it's to the power of. Don't just say this is not x2. X2 would just be x and then a normal size 2 next to it. This is x squared or x to the 2nd power. Now for number 2, we have k to the 12th power divided by k to the 2nd power. So we're going to keep our base of k, but we're going to go ahead and subtract our exponents, get 12 minus 2, and that gives us 10. So our answer is k to the 10th power. For number 3, same idea. We're going to subtract our exponents because our bases are the same. 3 minus 3 is 0. So we have m to the 0 power, and you should know that any number that is to the 0 power is always equal to 1. For number 4, it's the same idea. We just have an extra variable this time. Same process. So we're going to take our a's, and we're going to make sure we subtract those exponents, and we're going to use our b's and subtract those exponents. So we're going to start with the 6 and the 2. 6 minus 2 is 4, so it should be a to the 4th power. And then our b is b to the 4th divided by b to the 3rd. So 4 minus 3 is 1. So you could write it as a to the 4th power, b to the 1st power. Or you can write it simplified like it is on this paper, a to the 4th b. Because we know that b by itself means there is a first power, so you don't need to write it. This is the most simplified format, so this is what I would like to see from you. For number 5, it's the same process. Do the p's, subtract those exponents. The q's, subtract those exponents. So we're going to start with 7 minus 4. 7 minus 4 is 3. And then 16 minus 12, and that's going to get you 4. So we have p to the 3rd power, q to the 4th power. Now for number 6, we have 3 different variables this time. So same idea, x's, subtract the exponents. Y, subtract the exponents. Z, subtract the exponents. So with this one, we have 20 and 5 as our exponents for x. So we subtract those. We'll do 9 minus 9 for y and 2 minus 1 for z. So when you go ahead and solve that, you should get x to the 15th power, y to the 0, z to the 1st. Yes, this is a correct answer. However, you need to simplify it as far as it can go. We know that y to the 0 is always equal to 1, so that eliminates the y term. So we're not going to have a y in our final answer. In our z term, z to the 1st means that we just have z. We don't need to write z to the 1st. So our final answer is x to the 15th z. Now, sometimes you're going to have coefficients. Okay, so it's the same idea. The first step is to divide the coefficients. Now, it is okay to get a fraction here. You're going to want to have it as simplified as possible, but it's okay to have a fraction. Please make sure you're keeping it as a fraction and not changing it to a decimal unless the problem specifically asks for that. Okay, so we're going to go ahead and stick with number 7. We're going to try that one. So we have 6x to the 4th divided by 2x to the 3rd. So I know that 6 divided by 2 is 3, and then I'll subtract my exponents from my x terms. So 4 minus 3 is 1. So I have 3x as my final answer. Same idea for number 8. 14 divided by 7, we'll do that first. 14 divided by 7 is 2. And then I can go ahead and subtract my exponents. And when I subtract them, I'm going to get 2rs. That should not be to the s power. That should be s next to it. So it would really be like that. Okay, so for the next one, what we're going to do is we're going to go ahead and do the exact same process. We are going to go ahead and do our division first, and then we're going to go from there. So we're going to do negative 36 divided by 4. Negative 36 divided by 4 gives me a negative 9. And then we have c squared divided by c squared. Well, that's going to eliminate that c, right? Because 2 minus 2 is 0. And then we're going to do our d to the 5th over d to the 3rd. 5 minus 3 is 2. So it's negative 9d squared. For number 10, we're going to go ahead and divide. Remember, if you're dividing a negative by a negative, that makes your answer positive. So 15 divided by 3, or negative 15 divided by negative 3, is a positive 5. And then we have x to the 6th divided by x to the 5th. 6 minus 5 is 1. Y to the 5th divided by y to the 3rd is going to get me y to the 2nd. And then I have this z term here. And since the z is in the numerator and there's nothing here, it's like saying z divided by 1. So like, for example, if you do 2 divided by 1, you know that that's just 2. So here, z divided by 1, the answer is just z. Okay, so there may be instances, not yet, but coming up, where that z might be in the denominator. So if it's in the denominator, then you would leave a fraction bar and put the z. And I'm going to try my best to write that. Right now the pen tablet is broken, so. Okay, so if it looked like this, bear with me as it's very hard to read this. Basically, the only thing that changed, I put the z from up here to down here. So your final answer, when you simplified it, would end up being 5x y squared. But then since the z's at the bottom, it would be all over z. So that's just slightly different. If there's no z on the top, then you would keep it at the bottom. But in this case, there's a z at the top and none at the bottom, so you would keep it on the top. If that makes sense. So we're going to try 2 more, and that's going to be your turn. So for 11, we're doing 4n to the 5th divided by 8n. 4 divided by 8, you should know, is a fraction, and that's okay that it's a fraction. We're just going to simplify it. 4 over 8 simplifies to 1/2. And then n to the 5th divided by n, so that's like n to the 1st. So n to the 5th divided by n to the 1st, 5 minus 1 is 4. So you should have 1/2 n to the 4th. For the last one, we have 36 m to the 9th n to the 5th divided by 54 m to the 3rd n squared. So we need to do 36 divided by 54. You can do that in your head. You can do that in your calculator, however you need to do it. 36 divided by 54 is going to get me simplified to 2/3. And then I have m to the 9th divided by m cubed. So 9 minus 3 is 6. And then n to the 5th divided by n squared. 5 minus 2 is 3. So that's how you solve problems with dividing monomials.